Hello, everybody. Thank you so much for joining us today to discuss collision detection, mating or coming in contact or meeting with tolerance analysis. Presenting today is going to be myself, Gerhard Bell. I'm a dimensional engineer, ASME certified. Of course, I work for Dimensional Control Systems. And my colleague, Priya, variation analyst and instructor. And she is also, which is not listed here, but she also tests our software when we have new capability. Our agenda today is going to be to discuss collision detection, the difficulty in collision detection, and some new capability that 3DCS has developed. So what is collision detection? It's the ability to predict collision before it happens. You can see this advancing everywhere, especially in automotive, when I love the fact that I can put on my cruise control and practically go to sleep because the radar will slow the car down automatically. That's one form of collision detection. Obviously, if you get in an accident, you didn't detect the collision, but you know there was one. Collision in any form is not fun, in life or in the engineering environment. This picture on the right-hand side, that looks like it could be fun, but I guarantee you, if I was one of them in that event, I'd have to be hauled away on a stretcher afterwards. Of course, that's because I'm quite old. And in the engineering environment, if you have collision, that's going to cause assembly problems. You're going to have to rework stuff. So the goal is, can we predict collision during the engineering or development of a product before we go into production? Typically, detecting collision is very difficult. The CAD systems can do it, but they deal with perfect parts, and that's easy. They leave it to companies like 3DCS to do collision detection when you have variation. That's difficult. And even though it's difficult, we can do it right now. 3DCS can do it right now. But to do it, you have to write a lot of measurements, and you have to kind of guess where you expect there's going to be collision. Typically, anytime I'm talking to a customer, they say, "Hey, can you do collision detection?" And I get this sad look on my face, kind of like, yeah, but. Yeah, we can, but I tell the engineer, you need to kind of know where you expect the collision to happen. Where's your closest areas? Then we can tell you if it's going to collide, and you would write a measurement there. But it's not really easy, and it's not exact. And you may not pick the right spot. Well, now this is the exciting part. In DCS's attempt to continually answer the customer's questions or deliver the customer's wants or strive to advance the capability of tolerance analysis in that field, we now have collision detection. So finally, when a customer asks me, "Hey, can you do collision detection?" I can say yes. And we've done it by introducing two new capabilities, which Priya, she's way more efficient than I am. That's why I'm going to step out of this at this point, and I'm going to hand it over to Priya, and she's going to tell you about our new single measurement GUI and the multiple measure auto generator. So at this point, Priya, take it away.
All right. Thank you so much, Gary. That was a great introduction for this. So let me take over from here. So as Gary mentioned, yes, now we can do collision detection in 3DCS. And to do that, we have two new functionalities that we added recently to our software, to our mechanical modeler add-on. One is the collision detection generator. Another one is the path distance measure. So basically, collision detection generator, it's a GUI where automatically our software generates measurements for the user. And that generated measure is the part distance measure, which I'll cover next. So this GUI, it makes it easy for a user where they can just add the parts to it, and by just a button of click, you can generate how many measures you want to. That's
So,
the, yeah.
so what that means for those of you, if you back up one, for those of you that are familiar with our software and know about our measurement generator, we've already have a measurement generator where you can write X, Y, Z vector direction measurements, but you already have to have your points there, and you have to have the features that you want to measure. With this collision detection measurement GUI, you no longer are writing any measurements. You're just picking the parts that you want to check for collision between. And then this will generate the measurements that you need.
Right. And that generated measurement is the part distance measure, which is again a new function that we added. So basically what part distance measure does is it's an improved version of our existing feature measure we already have in our software. So basically you can add parts to it by manually, or you can have this collision detection generator GUI to generate the part distance measure, which automatically add the parts to it. So internally, how the calculation happens is it looks for all the features of the selected parts in your object part list and tries to measure with all the parts and all the features inside those parts from the two part list. And it gives the minimum distance that it has been detected so far with the given information and provides that to be the current value in this GUI. And you have to make sure that it does not really captures all the part information, but only takes in the features that 3DCS have used. For example, the features that you have meshed using any of the tolerances or moves that you have created in that modeling process. So basically, each part should have mesh in order to our GUI generator to automatically pick that information from them.
Perfect.
All right, so in this demo, I'll be using the 5-button mouse model, and the platform that I'm using for this demo is CATIA V5. And in this model, the area of concern, so the place that I'm concentrating to detect the collision is that area that I have marked, which is the gap between the buttons and also all the parts that surrounds the button. So at this point, I'm going to switch the presentation to my CATIA V5 page where I can show the model and walk you through the process. So I have the mouse model up. So this model is completely modeled with 3DCS where I have already have the moves that make the model to build and also have the tolerances already written. So now let me just quickly nominal build and deviate so you can see the model being completely done. So at this point, let me separate the model back and in the mechanical modeler add-on toolbar, let me pull this out so I can show you the new collision detection GUI, and also under that I have the new part distance measure function. To start with, let me start the collision detection GUI here. So I'm just going to click this. So the first thing that it pops up is asking under which level you want the measures to be generated. So here you can be a sub-assembly, a top-level product, or even a part. So here I'm going to pick the mouse, that's the root, and that's opening the collision detection GUI. So right here, if you notice the GUI, or it tells it's a collision detection measure generator, and it also says under which level you are generating this, and it gives you a default name from which the user can go ahead and change it. And coming down, I have the measure type. So the measure type, they have two different types. One is between all, another one is first to all. Between all is just it creates measurement between all the parts that you select in the list, and it creates and it makes sure it selects each and every part combination throughout the list. But first of all, it just picks the first part in the list and it tries to create the measurement with the rest of the all other parts down in the list. So that's the difference between these two measure types. And we
So,
have, yeah, go ahead, Gary.
so if I expand on that, if you said to between all, it's basically would be creating a combination of part one to part two, and part one to part three, and part two to part three, and all the combinations of the parts. But if you say first to all, then it's just part one to part two and part one to part three, if you only had three parts.
That is exactly right. You put it better, Gary. I was struggling with explaining that between all, but thank you. Yeah, that is exactly right. So it between all, it takes all the combinations in the part list, but first of all, it's just sticking with the first part in the list with the rest of the part in the list again. Yeah. So then I have the clearance zone, which I can explain in detail later, but this is a clearance zone which it helps you to minimize the number of measures that can be generated from the GUI. Then coming down the list, I have the specification limits. This is something similar to what we have in all our measures dialog, where you can set the upper spec and lower spec and set the spec mode as well. So here for this, this is defaulted to lower spec to be 0 and absolute because I'm curious to detect any interference that's happening. So that's why the lower spec is set to 0, and I'm going to proceed with that. And let me now, at this point, let me go ahead and start selecting the parts.
Wait, before you do that, what you're trying to say is because you're going to generate these measures from this collision detection measure generator, since it's a collision detection, that's why we set the defaults to absolute lower spec 0. And then we don't care about the upper spec because we're literally going to write measurements to look for collision only.
That's right. And the generated measures that, as I mentioned before, the collision detection GUI will generate the part distance measure. So whatever setting you add in this dialog gets carried over to the part distance measure. So that's how this works. So let me get started and start to add the parts. So as I mentioned in the PowerPoint, the area of concern would be the side buttons. So I'm going to start with that. So let me go ahead and pick that. So this is the first button that I'm going to select, followed by the other parts that in danger or that's surrounded for the collision area. So it'll be that, the top cover, left, and the base. It can be in any order, the selection doesn't matter. So now from here, I make sure my selection measure type is set to first to all. So now it's going to go down the list by starting with the first part. So the measure generator will be the first part, the side button forward to the back, then side button forward to the top cover, similarly to the left and the base. So that's how the flow goes. So at this point, I think I have all my parts selected. I have my specification limit specified, and the next thing I have to go ahead and generate it. So now just by clicking the generate button, it just went through the process that I explained, and it generated 4 measurements for this combination. Let me hit OK. I'm just going to close this dialog. I'm going to go ahead and look for that measurement in the tree. So now under measures, you can see how this collision detection generated a separate folder, and inside that you can see the measures that we just generated using the collision detection GUI. So as I mentioned before, so you can see the difference in the icon to just say the generated measures are the part distance measure. So you can, if I come down here, this is the part distance icon. So that's the exact thing that we've been using. So here, these are the part distance measure that got generated. So now let me go ahead and nominal build.
So you'll notice one of the things is previously in an early release of our software, we added groupings so that you could group, a bunch of measurements in one group or a bunch of moves in one group or tolerances. So we're utilizing that capability now. And that's why when she used the collision detection generator GUI, it produced that one group and put all the measurements in it.
Right. And at the same time, it's a nice way of categorizing. So you know if you have rest of the other measurements in the model, that would be in a separate group, or as you see, it's in the top level where the collision detection generated measures are grouped. So it's another way or to differentiate it and can easily access to. And again, this group name is defaulted, so which user can go ahead and change the group name anytime. And same thing for applies to the path distance measure that got generated. So now you can see now, right by just mousing over or by clicking on each measure, it gets highlighted something in the graphics, which says the from and to location. To get in more in detail or get to closer look of this, so let me just zoom into that part. So the first measure here, it says the side button forward to the side button back. So I'm going to zoom a little more closer and I'm going to mouse over it again. And you can see it's measuring the gap between these two buttons, and it also tells you exactly where it's measuring. So right there. So that's the from and to location, and that's the gap it's been measuring for that specific measure. So that's one quick way of telling if the part is nominally interfering or not. So now if I
So
zoom back,
what that means, Priya,
yep.
is between those two parts, that's the smallest gap, right?
Correct. Yes, exactly. So what it does, so now if I hit separate, so I can show you what it actually looking for. So now you can see how if I click on this measure in a separated position, those object features, it's getting highlighted in the graphics. Those are the meshed feature, what the GUI or what the part distance measure has been looking internally. So now if I double click this, you don't see any of those information in the GUI. So it's internally, it's just using all the part meshes, but just in the GUI, it just shows the part names in the from and the to part list. And that's, yeah, as you said, it's just going through each mesh or each feature from one part and trying to calculate the distance of all the other features in the next part. So in that way, whichever part or whichever mesh combination is giving you the minimum gap, that would be listed in this current box. So right now for this measure, 0.1 is the minimum gap that has been found for in its nominal position. So yeah, as I open the GUI now, so this is the part distance GUI, where again you can, as I mentioned before, you can go ahead and change the part name, and you can in future if you want to remove this part, re-add another part, you can definitely do that. And about the specification limit, still you can go ahead and change anything out here, and doing any change gets saved um, as this measurement and will not be overwritten by redoing the generation from the collision detection measure. So now that I have this all done, so I'm just going to close this. So this looks good. And yeah, so now first I just generated one set of measurement that I'm looking for. So similarly, I'm going to do the same thing for the back button. So here now I'm going to make sure that I select the back button and check for any interference that this button is surrounded by. So let's go ahead and do this whole process one more time. So I'm going to select the collision detection. Again, I'm going to put the mouse. So right here, I'm going to start adding the parts. So I'm starting with the back button in this case, so followed by the rest of the other parts. Now, in addition to this, I'm going to do it a little different this time. I'm going to pick the other cover button. And now you can see, okay, the right cover, that's the new part that I added for this measurement generation. So now I have that. Even this time, I'm going to still stick with the first two all because I'm just looking for these combination and I don't want the other combinations to be generated. And here, in addition to this, I'm going to use the clearance zone here. So as I mentioned before, if a user not really sure about how the parts are interfering, they can get this advantage of the clearance zone. So what clearance zone does, by setting this checkbox and giving a number, say for example 1 millimeter. So now, and yeah, the important thing I have to do is I have to put the model in its nominal position. So from here, it's just going to look for the gaps between the side button back to all the rest of the parts that I added to the GUI. And it makes sure that if those parts fall under this 1 mm zone, then generate the measurements. If not, please ignore that. So that's the rule that we are applying by setting this clearance zone. And for this example, I can clearly tell that the right cover that I added is nowhere near the back button. So I wanted to remove that. But there could be scenarios where a user really not sure if it could come on because there could be multiple parts in their model. So in that case, they can use this advantage and just minimize the whole generation process, which in turn reduce a lot of time in your analysis. So now here I have this clearance zone set to 1 mm, measure type is set to first to all, and I'm going to leave the specification limits as it is. So now,
Before you generate it,
yeah,
so what that means is by setting that to 1 mm, you're essentially saying that I only want measurements between any features that are 1 mm or less.
correct.
So it will eliminate writing a whole bunch of extraneous measurements that it doesn't even need to check yet.
Right, exactly. Yep. So now if you can see now if I go ahead and generate it, so this message will be even more clear for the user. It says, okay, we generated 4 measurement and the clearance zone prevented 1 from being generated. So which here we know that the right cover was not nowhere near to the back button within that 1 mm zone. So it eliminated this measure combination from being generated. So that's exactly the message says. So I'm gonna hit OK, and I'm gonna close this GUI. So now, as I told before, so any new collision generation or any new um, generation that we apply from the GUI, a new set of measures gets created every time. It does not override the existing one. So that's why I said you can anytime go ahead and change this information, and those information get saved to that part distance measure, and it will not get loosened by generating the GUI one more time. So now I have the measures generated. So now the next thing I have to do is just run an analysis and to see how see if there is any interference happening between the parts. So for this example, I'm just going to run the collision on the side button forward. So I'm just going to deactivate this for now, and let me quickly run the analysis. So let me move this away. So it's running the Monte Carlo analysis, and followed by it's going to run through the contributors, and we'll give you the results in a minute.
Yeah, so for those of you that are familiar with our traditional feature measure, I mean, that takes a long time if you have, a very dense mesh. And so this is still going to take some time, but we have a new algorithm which makes this much faster, which does give us the ability to, globally check between all the parts. Of course, it's not going to be instant. So when you want to do collision detection without having to think about it, the computer's got to do more thinking, and it will take a little more time.
Yeah, and as I said, it's just going through each mesh node at a time with all those builds. So that's the delay. All right, so now I have the result popped up. So now just by looking at the summary page, I see a tiny bit of redness in this last measure. So let me get into a deeper look at that. So that's a measure that was between the side button forward to the base. So now I found there is a minor interference happening in this between those two parts. And to check even more clearly, so let me move this away. So from here, let me do show min. So show min will build the model to exactly to that spot where it is interfering. So I'm going to click that. Okay, I see a small interference happening at that spot. So to even more clearly tell the location, so now I built the model to its min position. So at this point, I'm going to click on the side button forward to base. Oh, that's the interference. That's not the one. All right, there you go. So it's going to click on that. And if I hit current, So you can see it showed me a value of negative 0.12. So that's the location where it's actually measuring the min gap, and that's where it's measuring the interference between the parts. So let me back. There you go. Yes. So now if I hit OK and come back to the result page, so let me click back on open. So now we know where the interference is happening and what is the interference amount. The next step is to know what is the contributor or which is the top contributor that's contributing for this specific interference. So now from this contributor list, I can tell the first surface profile on the base is the top contributor. To give a clear ideas, I'm going to do is going to click that. I'm going to say visualize effect. So what it does, now I can see how that's one specific contributor is getting applied, and I can see how the part deviate for that. So now I'm going to hit continuous. Move this away. Yes, I think I saw a small crash happening at that point. So I can see there is a crash happening visually also for that specific tolerance. So now from here, I'm going to stop this. I'm going to pull the back that tolerance. I'm going to open that. I can see it's set to 1. So now at this point, I'm going to tighten it up to 0.5. I'm going then come back, going to close this. I'm again going to nominal build and run the simulation one more time to see if that tighten tolerance anyway make the interference look better. So I'm going to rerun this one more time.
So while this is running, I don't know if you guys noticed, but from the first option, when it showed there was a collision and she went back to that measurement, it's going to highlight where on the part it collided. It's looking at all the mesh, but then it's changing the to and from. So you can put it in the minimum, and then we will show you exactly where it crashed, which when I talked earlier that, hey, we can do collision detection without this, we would have got that same value if we happened to write a point-to-point measurement at that spot. Now you don't have to write that, and you can just run this, and when it collides, we can show you exactly where it collided.
Yeah, that's an excellent point, Gary, because when I ran this nominally, when I checked the gap, it was measuring here, right there. But now we would have imagined, okay, maybe we should look at the gap here for the further calculation, and or have written a feature distance measure between these two. But now we know after applying tolerance, the crash was happening in a different location. So that's why this collision detection is the new part distance measure is even more efficient, that we don't have to keep changing or keep writing measurements. So thinking about the new location.
Yeah, we don't have to guess.
Yes, exactly. So all right, so now I think we ran this result one more time after fixing up the tolerance, and I can now see there's no redness. I'm going to get into the measure one more time. And now if I hit Showman, so whichever the least location, and come back to that measurement one more time to see what is that new gap, where is it measuring? I'm going to click that. It says already it's measuring the same spot, but this time with the gap in it. So now if I hit current, there is a gap of 0.03 where there's no interference happening. So I'm going to hit OK. So now I think to summarize the whole process. So what I did, I had a completed model, which I wanted to make sure that there's no interference happening. So that's where I used this GUI, which in a button click, I just selected all the parts and generated the measurements. And now I had the measurements already generated. So now I ran the simulation to check the results, how it looked when the tolerance is being applied, where I found a spot where it was interfering, then which by just tightening up the tolerance, I made the model to work better where there's no interference happening now, and the new results gave me a promising answer, so I'm good here. So that's way we determined the location, and we solved this issue even more efficiently.
So, Priya, so you were showing how the collision detection auto-generated that measurement, but
Yeah.
you can, and you can, if you scroll up in the tree, you can see that these are just more measurements added you know, and she already deactivated all the old measurements that were in the model, which were just point-to-point measurements. And now we have all these dimension distance measurements. And if she wanted, she could write just a single dimension distance measurement between two features without using the measure generator, and it would do the same thing. It would use the same advanced algorithm to look for the minimum gap between those two features that you picked.
Exactly. So to just quickly show you that difference, so now if I click that, say I want to know the gap between these two covers, I'm gonna select that, hit close. Now in its separate position, let me apply and hit print. So now you can see there is the max gap. That's because it's in separated position. Here, let me close this. Then as I just wrote that new measure, you can see that measure gets added to the list. And now by clicking on that, as I showed you before, so it just highlights all the mesh that has been used in this model, and it tells you these are the mesh or these are the features that we are using for the calculation. So now from here, again, you can quickly nominal build, click on this measure. If I zoom into the location, that is the closest distance that is measuring between the parts. So again,
Cool.
this is a measure that I manually wrote using the new part distance measure GUI, and these are the measures that we generated. Another cool way of checking it is you can see how this measure does not have the small tiny icon. So that's way just to differentiate, giving a user a better understanding, saying that these were generated measures and this measure was created. So just an add-on information on that. So yeah, thanks for bringing up, Gary. So I was able to create that measure and show too.
And
Yep.
I didn't know about that little icon that
Oh
you
yeah,
just.
right. So we use this icon for our extraction. Like if you go ahead and do a GD&T or move extraction, we have the small tiny icon. So we thought we can use that for this because this is again a generation that a user did not manually do. So that's a way of differentiating, and the user can be aware of it. So yeah.
Nice, very nice.
So all right, I think yeah, I covered all the topics that I was planned to show you in this demo, and thank you.
Thank you for joining us.
Yep.